All right, guys, so today's topic is all about what we call imaginary numbers, which is a new set of numbers that you probably haven't talked about before. But everything on the left side of this chart are numbers that you have talked about and used before in your life. Like maybe even before you started kindergarten, you started talking about the natural numbers, which are also your counting numbers. So if you start counting something, where do you start at? 1, and then you would go 3, and so on. And then, sorry to interrupt the counting phase, but yeah, you would just keep going, and that's how you normally start. And then somebody tells you about whole numbers, which whole numbers is the same set of numbers, but we add on one more, because all of a sudden you realize that there's this number that means nothing, which is 0. So our whole numbers start at 0 and then keep going. And then when you get later on into late elementary, maybe even early middle school, you introduce integers, which are like our whole numbers, but it includes negatives. So these are like -2, and you can keep going that direction, -1, 0, 1, 2. So far, none of these have what? None of these have decimals. They're all what we consider whole numbers, natural numbers, but positives and negatives. Now, in elementary school, you also talked about rational numbers. All of these things below here are also considered rational numbers, but rational numbers can be written as fractions. Any kind of fraction is considered a rational number. So what are some examples of that? 1/2, 1/2. Good. What else? 3/8. And also whole numbers can be written as fractions, right? Like the number 3, we could put 3/1 will work. It reduces to just 3. So anything that can be written as a fraction is called a rational number. And you guys dealt with those for a long, long time. Percents and decimals that end can also be considered rational numbers. So like 23% or 7.25, because you can hit math enter on that and turn it into a fraction. Now, all of these are made up of what we call our real numbers, and we also have this one to the side that's considered irrational numbers. Rational numbers can be written as a fraction. Irrational numbers cannot be written as a fraction. That's right. So some examples of those are decimals that go on forever. They don't repeat, don't have anything in common, which would be... How about pi? Yep, our 3.14, which we call pi. Now, if you just say 3.14, then that keeps going. Luke, you need to close that Chromebook. 3.14 will stop, and you can turn that into a fraction, but pi keeps going on forever. Now, what is something else that keeps going on forever? How about the square root of 2? If you type that in your calculator and you hit math enter, it will never change it into a fraction. So a lot of these square root numbers that we have, if they're not perfect squares, then they are considered irrational numbers. Now, all of that is made up of the real numbers, and that's all the things that you're used to using, right? You've used all those numbers before. But that brings us into a new kind of number. Well, if it's not real, it's imaginary or fake, but imaginary is the one we go with in math. So to get an imaginary number, you square root a negative. The square root of -1 is this imaginary I, and we typically write it as a cursive or italicized if it's in print. So the square root of -1 is I, and that's our imaginary number and where it comes from. Now, all of these numbers are part of complex numbers. Complex numbers are a combination of real and imaginary. A lot of times we say complex numbers are in the form A plus BI, where A is like a whole number, integer, rational number, and then B is your imaginary number. So today we get to learn about, hey, what about these imaginary numbers that could show up? Imaginary numbers are used a lot in coding and computer science stuff. So if you're ever going into that major, you'll talk about imaginary numbers. And they're used a lot in business and looking at money because imaginary numbers can show up on graphs. But we can't see them, but they are actually there. So you can kind of research more about imaginary numbers to see how they're used in different fields. It may be something that you're interested in. Now, if you're probably planning on being like a nurse, you probably won't see imaginary numbers. If you're planning on going into landscaping and mowing yards, you probably won't see imaginary numbers. But if you're going into some kind of upper level like business models that deal a lot with finance and money, you might see some. Computer science, you would see some as well. All right, so let's look at taking some square roots of some negative numbers. If you want to just write these down one at a time as we go through them, that would be great. So let's start with our first one here, square root of -4. Now, what I want you to think about with this one is splitting it into two numbers. This can actually be the square root of -1 times 4, right? That means the same thing. So if you kind of ignore that part with the -1, you just have the 4. What's the square root of 4? 2. And then we just wrote down what's the square root of -1? It's the I. So the square root of -4 is 2i. All right, grab your calculators. I want to show you a little trick on your calculators, and this will definitely help you. If you have your calculators in the mode that it currently is, most of you are going to type in square root of -4, and it's going to say error. Non-real answer. It's not real because it's imaginary. You can change the mode of your calculator. So if you hit mode up here at the top, see down here on the side where it says real? Well, beside real, it says A plus BI. That is making sure your calculator is in complex mode. So it will deal with real and imaginary numbers. So go on your calculator and find where it says A plus BI and hit enter on it to where now that is highlighted. Now, to get out of this mode function, notice it says quit above mode. So if you hit second mode, it will take you back to the home screen. And now you can type in square root -4 and it gives you 2i. So there you go. All right, let's look at problem number 2. So you guys write down square root -15. Now, before, what did we do when we saw square roots? Like yesterday, when we saw square roots, we would do what? Make the factor tree, right? You're going to be doing the same thing here. We're not going to be rounding these to any decimal places. You are going to make a factor tree with them. So 15, what multiplies to be 15? 5 and 3. Remember, we're looking for any pairs. Do these have any pairs? No. So the square root of 15 cannot break down. But because of this negative right here, we have to take out an I. The I always goes in front of the square root. So it's like, remember how we said you can't leave a square root in your denominator? Well, I call that the second math commandment. The first one is thou shalt not divide by 0. The second one is thou shalt not leave thy square root in thy denominator. And then the third is thou shalt not leave a negative under thy square root. So no negatives under the square root. To get rid of them, we use the I. Okay? If it doesn't break down, the I goes in front of the square root. So write down number 3, square root -50. 50 can be broken down. You're right. What multiplies to be 50? 5 and 10, sure. What multiplies to be 10? 5 and 2. So if we look at this problem, we have a and a 2 left over. Now, what comes out of the square root? The 5, but also we're going to pull out I, the negative, which would make the I. So this is going to be 5I square root 2. That's how we break down square root 50. So really, the only thing we're looking for, if it's a negative, we take the negative out and change it to a I. All right, let's do square root negative 360. Now let's make that factor tree. 36 and 10. 36 is 6 and 6. Somebody gave a little helpful hint the other day. I don't think it was in this class, but they said, hey, when you notice a pair, can you stop? You can actually stop if you want to. That's a pair of 6s, right? So that means that's going to come out. Now, if you want to keep going, you can. You can have your 3 and 2 and your 3 and 2. And what's 10? 5 and 2. So if you look at your pairs, we have a pair of 3s, we have a pair of 2s, and this 5 and 2 are left over. So what you have a pair of, what happens to the pairs? They multiply together on the outside. So 3 times 2 is 6. And don't forget what needs to go with it. Very good. And then we'd say square root of 10, because 5 times 2 makes 10. So it's the answer for this one is 6I square root 10. You guys try these bottom 4. So try them out on your paper. Make some factor trees and put some I's in there. I believe that these are correct. Let's just go through them. So the square root of negative 25 is 5i. Good job. This 5 does not break down, so we have to put the I in front because commandment number 3, thou shalt not leave a negative under thy square root. And then question 7, when we break down, we got 12 and 10, 6 and 2, 5 and 2, and then we got 3, 2, 2, 5, 2. So we got a pair of 2s, 3, 5, and 2 left over, so don't forget we multiply those. So 2i square root 30 is correct. And here, breaking down negative 54, we have 6 and 9. So a 3 comes out, the 6 stays underneath. So that works out. So, yep, just making your factor tree, break it down, and don't forget to put an I in front of the square root, but after the number. So y'all feel okay with breaking down square roots? Now we're going to solve some equations that might have these in them. All right, so write down maybe number 1 if it decides to change. Now, don't forget, if you struggle with finding those numbers, you can use the hint that we used 2 units ago, going to y equals and typing in. Yes, the number divided by x. So if you're struggling with 54, go to y equals, type in 54 divided by x. I would do it without the negative, and then it will list all the factors for you. And then you can start making the rest of your factor tree. So go ahead and write down number 1 there. This is solving quadratics. I guess I could put a title on here. Solving quadratics with square roots. Now, don't forget to write down that little hint there. That's going to help you if you ever look back at these notes, especially for studying and reviewing for the test. We're going to solve these quadratics with square roots, and we can do that when there's only x squared in the problem. So notice all of these have x squared, no x term. So it's just x squared, no other x term in the problem. So with problem number 1, we're going to solve for x like we normally do. Get x squared by itself. How are we going to do that? Divide by 3 first. So get that x squared by itself, and then we get 8 on this side. And then how do we get rid of a squared? You do the square root. You're exactly right. We're going to square root both sides. Now, here on the left side, we're going to get x. Now, when you square root, the same thing as a square root is that fraction exponent of 1/2, right? The bottom number is even. What do we do when we take an even root? Plus and minus. So with all of these, you're going to have to put plus or minus with your answer. So anytime you take a square root when you're solving, put that plus or minus. Now, is 8 a perfect square? Nope, so we have to make a factor tree. What multiplies to be 8? Good. So we have a and a 2 left over. So the square root of 8 would break down to 2 square root 2. Did I need to put an I with this one? Correct. No I because it is not negative, so that would be our final answer. So some of the problems you have tonight, you're just breaking down a square root and putting a plus or minus with it. Some of them might have an I with it. All right, write down problem number 2. 5x squared minus 180 equals 0. Now, if you need to, this would be a good chance for you to write down some steps to the side if you think you're going to forget how to solve these later on. You might want to put steps. So what should I do first? What's step 1 on all of these? Get x squared by itself. So if you want some steps, get x squared alone. All by itself. Need to work on that. But let's get x squared all alone, all by itself. What would I do to get x squared by itself? Correct. So first, remember, you're doing your order of operations in reverse. We want to add or subtract. Then we would divide by 5, because then we multiply or divide. So we're divide both sides by 5. So x squared equals 36. And now that x squared's by itself, what do we need to do? Square root. And then you might want to make a note. Don't forget to put what? Plus or minus. So let's square root both sides. So x would equal plus or minus 6. That's right. 36 is a perfect square. I like when it's a perfect square because then we don't have to do anything. If it's not a perfect square, we need to break down the square root. You can make a factor tree, however you remember, if it's not a perfect square. All right, question 3. 4x squared equals 25. Now, while you're writing this down, you might recognize something about those numbers. 4 and 25 are what? They're perfect squares. So if you notice things are perfect squares, leave them as they are. So what I mean by this is our first step here, we would want to divide by 4, right? Don't type that in your calculator. Leave it as a fraction. 25 over 4. So don't type it in your calculator. You don't need to reduce it. You don't need to do anything else right now because we're not done solving. But at this point, those are perfect squares. Leave them how they are. So now we would square root both sides. So x would equal, don't forget, plus or minus. And what would that equal? 5 over 2. You're exactly right. We just square root the top and the bottom, and so x would equal plus or minus 5 over 2. All right, question 4 is coming up next. X squared plus 25 equals 0. What am I going to do first on number 4? Perfect. So x squared equals negative 25. Now the x squared's all alone, so we need to square root it. Let's square root both sides. That's exactly right. Because the square root of 25 is 5, but because it's negative, we got to put an I with that answer. And don't forget the plus or minus. Okay, question 5. 3x squared plus 2 equals negative 64. What do we need to do? Perfect. So 3x squared equals negative 66. Then what? Divide the 3. So x squared equals negative 22. Then we would square root. So x equals, don't forget, Now we look at that number 22, right? We would normally go to the side and make a, what multiplies by 22? Any pairs of partners? No. So what do I do with that number? That's right. Bring the I out and leave it as a square root. So if it doesn't break down, you need to leave it how it is. Okay? So if it's a perfect square, the square root goes away, and that's the only time. If it can't break down at all, leave the number under the square root. But if you can break it down, break it down. All right, I got one more problem for us to do that I forgot to write up here, so I'm going to make it up on the fly. I hope it works out. Let's see. 3x squared equals, let's say 10. Now, what would you do? Divide by 3. Can 10 or 3 go into 10 evenly? No. If you type it in your calculator, you get the long decimal, which means that you need to leave it as a fraction. You would hit math, enter, enter. It wouldn't reduce, so you would leave it as 10/3. Now what would you do? Square root both sides. Now, again, when we square root, x would equal, don't forget, plus or minus. But can I take the square root of 10? Can I take the square root of 3? No. So the square roots actually have to stay with both numbers. But commandment number 2, thou shalt not leave a square root in thy denominator, right? So if I were to kind of split this up, it would be square root 10 over square root 3, which we cannot have. How do we get rid of it? We have to times by the square root of 3 over the square root of 3. So sometimes what we did in that last unit, rationalizing the denominator, pops back up. So you got to recognize that and be able to simplify it in the correct way. So on the top, if we multiply straight across the top, we get square root of 30 over just 3. That's right. The square root of 3 times square root of 3 just makes 3. Now, if you can simplify more, always do that. But let's look at 30. If I went to the side and made a factor tree with 30, it would be 3 and 10 is 5 and 2. So do they have anything in common? No. So you might see a problem like this. I don't know if I put any on the homework, but if I did, make sure that you simplify as much as possible. No square roots in the denominator, so rationalize the denominator. Anything under a square root has to be simplified and broken down. Okay, we got one last thing that we're going to do today. If you notice, each slide has been a little bit different. We broke down square roots. Here we solved equations. And the next slide, we are going to do operations with imaginary numbers. Y'all don't even know what it is, and you're already whining. This is the easiest part. Write down the first problem there. I know I called it number 6. You can renumber these if you want to. I think I'm going to renumber them. Let's renumber them. Okay, now the first problem. Hopefully you've got let's write down just the first one. Make sure you got plenty of room. It says in parentheses 2 plus 4i plus in parentheses 4 plus I. Treat I like a variable. Treat it like x. All we're doing here is adding. You can only add things that are similar, things that are alike. So I'm going to add 2 with 4. And then I'm going to add 4i with negative I. So what is 2 plus 4? What is 4i minus I? Boom. Answer done. Yeah, now, can y'all stop your whining? Not really. All right, question 2. Write down question 2. Yeah, but you cannot put 6 and 3 together because one's got an I and one doesn't have an I, so it's just like X. One has an X, one doesn't have an X, so you can't put them together. So here we have a minus sign. Now, what do you do when there's a minus between the parentheses? That's right. You got to distribute that negative or flip the sign of the second parenthesis. So we have 12 plus 5I minus 2 plus I. So distribute that negative and then combine your like terms. So what would my final answer be? 10 plus 6I. Now, if you write 6I plus 10, I'm not going to count it wrong, but just know that in the, math universe that we live in, we normally put the real number, which would be the 10, and then the imaginary number, which is the 6I. All right, write down number 3, negative 2I times 5I. What's the answer? Negative 2I times 5I. Negative 10I squared. That is correct. Now, have we talked about I squared yet? No. I want you to go back to that chart that we did at the very beginning. We'll see if mine's going to take a second to go back. But we listed under imaginary numbers that I, how do we get I? The square root of negative 1, right? So when we do I squared, we're going to put a squared on this, which means we have to put a squared on that. So what does I squared equal? Negative 1. Because when we put a squared on this side, we have to square this side. The squared's going to cancel out the square root, so I squared equals negative 1. So let's go back to these problems that we were just doing and make you a big star and a big note and put I squared equals negative 1. So that means you have to replace any I squared with negative 1. That's right. So the final answer there would be 10. So that's a little trick that you need to know and you need to memorize. So anytime you end up with an I squared in the problem, it has to replace with negative 1, which is essentially just going to change the sign of the number that's multiplying. All right, question 4. Let's write this one down. 8 plus I, and then in parentheses 2 plus 7I. What are these two parentheses doing here? Multiplying. So be careful when you see tonight's homework and tests and quizzes. Always look between the parentheses. I can't tell you how many times I saw a lot of people trying to distribute problems like number 1 and 2 and foiling them out. So look in the middle. Yeah, when you get a lot of numbers, that's a good hint. So here we got a FOIL and distribute. So let's multiply them out. 8 times 2. 8 times 7I. 56I. Is it going to be a squared on that one? Nope. What's I times 2? And then what's I times 7I? 7I squared. Now, we just talked about I squared gets replaced with negative 1. So this last term is going to change to negative 7. Now, you can bring down everything else if you want to. So it's 16 plus 56I plus 2I minus 7. We got like terms to put together, so let's put them together. So 58I, and the first number is what? 16 minus 7 is 9. So your final answer is 9 plus 58I. All right, last problem of the day. That's right. You're going to have to multiply it, but you're going to have to double it. Anytime you see a squared, you're going to have to write it twice, because a squared means that you are timesing it by itself. So anytime something is squared, write it twice. So you can't distribute the squared over a sum or difference if it's a plus or minus. So let's go through and FOIL it out. What's 2 times 2? What is 2 times negative 3i? Then negative 3i times 2. And negative 3i times negative 3i. And what do we know about I squared? Good. So if you want to write it back out and change the sign of that last term, getting rid of the I squared, because I squared is negative 1. So positive 9 times negative 1 changes to a negative 9. Then combined up those like terms, we get very good. And that would be our final answer. All right. Your homework tonight is the worksheet, so it's in the same order that we did the problems in. So the first 10 problems, you're just breaking down that square root. You don't put a plus or minus if you're just breaking down. Then the next 1, 2, 3, 4, 5, 6, 12 problems, you're solving for x, just like we solved for x before. Follow the steps, get x squared alone. And then on the back, you're doing problems like this. Now, if it's an addition problem, you don't have to show work. If it's a multiplication problem, make sure that you show your work, okay? So show work with multiplication on the back.